Hello, this is the Literary Guild's first edition. I'm Haywood Hale Broun, and the guest today is a man who's extremely hard to describe, because I could say that I am talking to philosopher Buckminster Fuller, or engineer Buckminster Fuller, or inventor Buckminster Fuller, and he would say, why must people be categorized? Because he does not believe in specialists. He believes in putting together all that we know in the hope that that will give us something new to know. What I'd first like to ask you has to do with an optimism that you don't have many people joining you in. You feel, if I am correct from reading your work, that we have infinite technical and natural resources, that the world, if it doesn't kill itself in a war, is ready for the best of times. Is that so?
I don't allow anybody to call me an optimist and let it stand, or a pessimist, because I think both optimists and pessimists are a little off one side or the other. I hope I'm very realist. I do know by actual experience and study that humanity can really make it. The working assumption of all the great states and all the great political parties, all the great ideologies, is that there is not and never will be enough life support for all of humanity. That's the only reason we really have politics, because there's always been this lethal condition, and the ideologist, politician says, I have the fairest, the most logical way of getting on with fundamental inadequacy. I can't guarantee you're going to like it, my way, but this is the best way to carry on. You have less chance of being shot and less chance of dying of starvation. And I know then that in all, fundamental to all economics, is the basic model is scarcity. So that I have discovered that through human mind discovering principles, we have gradually discovered how to do more with less, and gradually, just very simple things such as to get a message across the Atlantic used to take a ship 3 weeks, and a very big ship. Now we can get across there at 700 million miles an hour by radio with only a few pounds of apparatus. So that the doing more with less became very exciting to me at the time of World War I, because I realized I was living in an advanced mechanical state of Navy, of aviation and electronics and so on. I said it could be that the working assumption of all the great ideologies is invalid. We might be able to someday to do so much with so little. We might be able to take care of everybody.
Well, you've also said in one of your works that you felt that the really great menace to all of us was politicians, because most of their work, as you wrote, was toward the preservation of their own jobs rather than to the preservation of our lives.
That's what happened after the dogma of a great political conceiver, Karl Marx or Lenin. We have then this going on into the dogma of the party, and so in bureaucracy there's no thinking. Everybody knows what the rules are. Well, now that's our great danger, because I'm sure that human beings are in this universe for a very good reason. I can't find anything in the universe that does not have some complementation of something else, and that we have the complex capabilities we really do have, and particularly the capability of mind in contradistinction to brain, that we don't know of any other phenomena having the capability to discover principles, behaviors operating between, that are not in any way predicted by any of the parts of the cooperating team when you're just looking at the parts separately. That is, there's nothing in the moon, chemically, geometrically, physically, that says it's going to attract another body, nor in the earth or any of the great celestial bodies. That is, as Isaac Newton, after Kepler and others' work, suddenly discovered, yes, there's this attraction between. Not only was there attraction between, but the distance between them varied arithmetically. The inter-attractiveness varied at the second power. Very extraordinary, this exponential rate of gain. And so suddenly the astronomers with this law were able to explain a very great deal of our universe. But the point is, mind and only mind could discover this relationship between, because brains are always and only coordinating the smelling, the touching, the seeing, the hearing, developing packages of concepts, storing and retrieving, but always special case. And mind is able to discover generalization that in order to qualify as generalization has to be eternal. So this is very different, very extraordinary matter we have. That's mind.
It occurs to me that those of us like myself who are not philosophers, engineers, inventors, or explorers of much of anything are sorry that we don't have Ptolemaic astronomy anymore. I like to think of the Earth as the center of a very small universe, and it is characteristic of intellectuals today to deplore these scientific discoveries which have made man in many ways seem less and less important. And yet again and again in your work I find a certain joyousness at the expansion of the universe in which man lives. This doesn't worry you, the largeness of the universe.
Because, oh man, I have really not just done some thinking, which we all do have the capability to do, but I have made up my mind to always reduce problem solving to artifacts instead of trying to persuade people to behave this way and that way, not just talking to people. And when I have an artifact which I can conceive of solving a problem, I must not talk about it until I reduce it to practice and prove to myself whether it really works. And then people come along and say, what is that? And I'll tell them what it is, and after a while some emergencies occur and nothing else will work, so they begin to use it. But my knowledge is such that because I've gotten into, for instance, just to what we need to enclose space to give human beings a really very adequate and very pleasant, desirable environment control, and in contradistinction to fortresses, piles of stone of yesterday, I have now discovered that is literally highly feasible. The resources we now have, even with mind, they're recirculating all the time. With the knowledge we now have, with the energies, just not fossil fuels, not atomic energy, just the income energy, I now know is highly feasible to take care of all humanity at the highest standard of living that anybody's ever known, and do it by 1985. That's why I know that the great, let's say Russia, China, United States, NATO, annually for the last 20 years, appropriating $200 billion, getting ready for Armageddon on the basis there's not enough. It has to be you and me who are going to have the great showdown. And I now know then that because this is all on the basis of not enough, and I now know there is enough. Therefore, I know that politics are really obsolete. I know the war is obsolete. I know the weapons are obsolete, and so forth. This is a very extraordinary matter to be in such a position. So the point is that I know it is so, and I'm being asked to speak to a great many people this last year. It's amazing to me, but I was asked to give 150 major lectures of 1,000 to 5,000 people, approximately every other day, and they're sitting out there, and I can make them see that they have an option they didn't know they had. And because they suddenly discovered that humanity has an option they didn't know it had, then they feel a little better because they had been assuming they didn't have any option. Then they say, your optimism rubbed off on me. It was not my optimism, because I have a slight idea whether we're going to make it. I feel absolutely touch and go every second whether the human beings really going to be able to make it on this planet. But the point is I know they have the option and they didn't know it. That's the difference.
Well, you said at the beginning of what you were just saying now that you always try to solve a problem in a sort of pragmatic sense. And early in one of your books you say that as a boy you solved a great many large problems with pieces of driftwood and a pocket knife, that you would cut something out and make a shape or a design, and then from that you proceed to a philosophical answer. Is that why you like to have what academics would call a cross-breeding of disciplines? In other words, you don't think someone should just be an engineer or just be a philosopher or just anything, that it is only through knowing as much as you can that you can put answers together. That's what you think, isn't it?
When you do get into science and you do begin to really check these great scientific discoveries that mind has discovered, there are always relationships which can only be expressed mathematically. And you discover that none of them ever contradict any of the others. There really is a pretty small family of generalized principles. Now, these generalized principles, then, could not be qualified unless they hold true in every case. So I discovered then, instead of trying to learn about all the special cases, which the specialist tends to do, all I have to do is to know my generalizations. And then they were going to hold true anywhere. For the years 1938 to 40, I was the science and technology consultant on the staff of Fortune. Russell Davenport brought me on there, and to highlight the scientific and technical backgrounds of these great corporations, where the other editors are always highlighting just the business acumen of the management. So that I found that as I came to each one of those big corporations, the scientists would say, there's no way you can tell the Fortune reader what it is we're doing in depth in our company, because it can be only expressed mathematically, and the Fortune readers don't read the mathematics. I was always able, to the complete satisfaction of those scientists, to tell the Fortune readers in words that went to their own senses, so that they personally could really feel and understand what I was talking about. So I've been really very interested in that gap, and I really had good fortune to know very many very great scientists, and they tell me that I can talk with them in depth about their subject, to their absolute surprise, and all because I have my generalized principles. Now, there's a language difference, ethnic language, industrial language, and professional. Break through the language barriers, and they're your principle.
We're talking with Buckminster Fuller. And you were saying, Mr. Fuller, that once you get through a language barrier, pretty much everything is explicable. It comes from, you say, a fairly small group of principles. Do you get impatient when you voice what seems to you a fairly simple principle and people don't listen?
Number one, oh man, when I started doing what I am doing, which is at the age of 32, 927, I made up my mind to really reorganize my life. I made up my mind never to ever ask anybody to listen to me ever again. I said I'll only talk to people when they ask me to talk to them, because I'm sure that's the only time they're interested. That's very basic. And I said I also going to confine myself to artifacts and not trying to ask anybody to look at my artifact. If I see that people have there's life support on the other side of a raging river here, and the people need to get across to get some of that life support to match the major life support on this side of the river. And I see man after man gets lost crossing that river. Sometimes they get across all right. If I build a bridge, I don't have to say anything. The people just start using the bridge. There'll be less people lost. This is my concept of artifacts, what I mean by solving problems. So that, inasmuch as I only work on an artifact, I found out whether it really does what I think it should be, and then I just leave it and don't ask anybody to look at it.
Well, you define scientists in one of your writings as left-handed scientists and right-handed scientists, by which you seem to me to mean that right-handed scientists were those who accepted the accumulated previous body of knowledge and proceeded from there, and left-handed scientists were those who questioned everything, questioned what is called in academic terms, I think, the zeitgeist, a system of physics or a system of whatever, and said maybe there's an answer based on something entirely different. Do you suppose that we have enough left-handed scientists, or are they always in short supply, those who are truly original?
That was not my invention, this definition. This is a very great physicist at MIT, used to be head of the physics department at Cornell. And I liked his thought, and I was simply really elucidating his the left-handed scientist is then one who really does dare use his intuition. And there was a time in the 20s, pragmatic 20s, where the word intuition was just a dirty word, and the scholars didn't like the intuition, and they felt that science was getting so hard and capable that science could solve anything. People who had scientific education then began to be feeling that inasmuch as man has these principles, he can lick everything, and therefore we came to atheism. It was very readily fostered by the scientists. Didn't find that anything he was finding seemed to have congruence with what he'd learned from any of the religions, and he seemed to find we solve everything. So he became really very atheistic. I mentioned earlier Isaac Newton then, and Kepler's series of events. I've Copernicus, Kepler, Galileo, and then Newton, and finally actually discovering this mass interactiveness and being able to actually get the mathematics of it. When you get to, if you really go through those things with the individual himself, go back and find out how he found out what he found out, we find Isaac Newton and finding this relationship existing between. So if you ask Isaac Newton, what is the gravity? He said, I obviously can't tell you. It's a behavior, and I can tell you how it behaves, but I can't tell you what it is because there's nothing in any of the bodies that are interacted that tells it's going to happen. So if you come to the beginnings of a great scientific discovery, you come to a priori absolute mystery, within which absolute mystery, this most lucid and beautiful behavior is identified as occurring, but no explanation of it. So we find then, to me, as I get all the great scientific discoveries, they always emphasize this a priori great mystery, from out which man then becomes so preoccupied with what he discovers, he forgets the mystery from the a priori mystery from which it was discovered.
You have a word which is substantially your own, about which you wrote a very large book, and the word is synergetics. Without giving all the explanation that there is in that large book, basically what is the core of the concept of synergetics?
Well, fortunately I've really already covered it, because it is synergy means behavior of whole systems unpredicted by behavior of any of the parts of the system considered only separately. And so for all the great scientific discoveries are always synergetic. I find the word getting to be better known. I'm glad of that in the recent last couple of years. But that's what's conditioned. Now the fact then that synergy is the only word that means behavior of whole system unpredicted by behavior of the parts considered only separately. It's a little like Gestalt, which is the sum being being more than the whole being more than the sum of the parts. But this is a little different. It's not just a sum. It is a behavior, which is very, very different. Now, the fact that all the great scientific principles demonstrate that so, and it's not a popular word, obviously not a popular word. Therefore, it's indicated to me that the populace is not thinking that there are behaviors of wholes unpredicted by behaviors of parts, so they found the word, they needed the word to describe what they were thinking. Therefore, I see society has been quite happy to be specialized, to be made to specialize. They feel that you add the parts up, it's all going to add up, they say. So now this makes me realize how society is one reason why less than 1% of humanity are in science, and the number who really would understand and feel synergy would be the left-handed scientists, the ones who really deal in intuitions and realize that our a priori great mysteries and pay great attention to the mysterious. Just give you a very quick little rundown on that particular part on the intuition. There were two, Northrop at Yale and another professor, quite independently, made studies of the letters, diaries, and letters to and from great scientists who everybody acknowledged had made great discoveries. And they looked through those papers to see if they could, and they only studied the papers just before the man made his discovery, at the time he was making it, and for a little while afterwards, see if they could find anything in there where he indicated how it happened that he made his great discovery and so forth. What was anything more important? Both of these investigators and writers found common to all their cases they had studied that the one thing was common was the intuition. They all said it's really like what I use the word cosmic fishing. You're suddenly your line out in the universe, in the blue, you don't know where, but that's your intuition. And suddenly there's something jerking on it, and you take a second look over there, and you may be able to pull that fish in. But these scientists then say the number one most important item in their discovery was their intuition. Then they also say, which is fascinating, then the next most important was the second intuition that came a flash after the first intuition about how to hook that fish. I'm terribly excited about this. Maybe I'd light a cigarette and go off and have lunch, and you forget about it. It's very easy. Many people exposed to very extraordinary ideas. I'm sure you do it. Many human beings, but they don't do anything about it right now, and it goes out, and then later on they say, I wish I was thinking that 5 years ago. I wish I'd done something about it. Anyway, the scientists do hook those fishes. Anyway, intuition is quite clearly back in accreditation of the thinker.
What you were saying now in following these discoveries was in a sense the same, that each intuition sparks another intuition. When do you think we might run out of intuitions? Or is the human mind vast enough?
There is never, as we make a great scientific discovery, you didn't know you were going to make it, but you do. And we're gradually pulling apart a curtain, and I said these principles to qualify as generalized principles cannot have exceptions. That means they're inherently eternal. Our brains do deal in special cases only, and all the special cases are terminal, and our brain itself is terminal. So we tend, human beings, their brain asks for beginnings and endings of universe, or beginnings and endings of everything. But suddenly, mind has discovered something eternal, these principles. And I want you to really realize quite powerfully what I mean by that principle. For instance, it's the principle of leverage. And you've used the lever many times, and then we have the fulcrum and the workload, then go out equal distance on the lever arm as you're out to the workload, and have 1-to-1. Go out two lever arms, 2-to-1. Little man can get pulling maybe 50 times his own weight if he has a strong enough lever. You have then mathematics of it, and you say, well, now let's design a generalized lever. No, it can't. It has to be a wooden lever or a steel lever, whatever it is. You have to always come back to the special case. But mind can deal in this generality. And Galileo made very clear with that same mathematics, it didn't have to be a pole or a bar. You could have a piece of rope going through a pulley and back-to-back pulley, and every time we got through a pulley, one of those lever arms, so it could be in tension and compression. I want you to understand that the mathematics is absolutely independent of the special case. It's terribly, terribly important.
Well, now, in a sense, we have heard that, and very encouragingly, that where we think there's a good deal of chaos and things flying off in all directions, if you look closely, you can hear what the ancients with an intuition called the music of the spheres.
Mm-hmm.
This is the end of side 1. Please fast forward the cassette to the end, and then turn to side 2 for the continuation of this program.
In one of his essays, Albert Einstein said, "What I cannot understand, I ascribe to the realm of religion." Does that seem to you a sensible remark, or do you think that there will always be an extension of understanding so that perhaps finally religion will be just a mystery of intuition?
I don't know when he made that remark, and I'm sure that you've been able to identify it in his writing. But it certainly, as the years went on, and I met the old man and talked to him, and I wrote 3 chapters about him in one of my books, Nine Chains of the Moon, back in '38. In his later years, he talked about the great mystery itself. This which drives him on all the time. It was the inspiration of that extraordinary mystery, continually, out of which suddenly came a new great truth that really inspired him. So that I don't think he really, as he matured, suddenly he was not holding the first thought you gave me there.
He had written that whole group of essays, Out of My Life and Work or something,
Right.
one of those academic titles early on, but also in that same book, he spoke of his then considered continual expansion of everything, and he speculated that there might come a time when expansion comes to an end, when light goes out, when motion stops, when it can be said that time has a stop, since time is the measurement between two happenings. But he supposed, and this I suppose is where he went into the realm of mystery, that there would still be some tiny force, perhaps no more than the pressure of starlight, which would start the whole process beginning again, and that then time would never have stopped. So that many of the things that he said, which are, I'm sure, comprehensible to you, to the rest of us come out as poetry, something vast and dark and not quite understandable. What you have been saying today is that you can pretty near always make some sort of little form or design or drawing or machine which will make the mystery clear. It's an encouraging thought.
No, I said, sir, that I assume a priori mystery and eternal mystery, that we'll find out so much. I have seen, there's no suggestion to me that man has exhausted the mystery. No, the more I learn, the more mysterious it all becomes, that there could be human beings who are designed as we are, our brains, for instance, representing billions of atoms in most extraordinary mathematical coordination, with you and I not thinking about them in terms of atoms, that you and I are only aware of very, very little, and we're almost completely automated. our breathing, our blood circulating, all those things going on, the making of cells. We have anything consciously to do that. So that this is all compatible with the special conditions of this biosphere, this particular little Earth, where you now we're 70% water, all the human males, and this would freeze, and we are in an atmosphere where we don't tend to freeze. The average thermal condition is absolutely superb. We don't know of any other planets like that there could be this particular set of technologies and all the intercomplementation you can find in the ecology of a strange little plant here in the Amazon, plays a game, and the particular little insect that's dealing with that. The whole universe, the whole of planet Earth, depending on all these interplays. So it is such an extraordinary design to me. There's such an extraordinary integrity that I know that when I started to do, in 1927, I started to do my own thinking at the age of 32, and I said, if I'm going to have to do my own thinking, I'm going to give it, best I can, all the beliefs that I've had. That my grandmother said, "Down, you're very tiny and you're young, you know how much I love you," and such went on 2,000 years ago, and you just take my word for it, because a lot of it's been checking up, and we tell you this great love and good faith. So that I said, as much as I'd seen how moved so many human beings had been by some religious fervor of one kind or another, and many, all kinds of religions around the world, I said, if you're going to go on your own thinking and going only on your own experience, do you have any experiences which suggest to you that there's a greater intellect operative in the universe than that of man? I said, I'm really overwhelmed by it, because these principles, because I had enough science to really be deeply moved by these, because these can only be discovered by intellect. They can only be discovered by mind. They're not discovered by brain. They're purely intellectual abstractions. Therefore, and when I then find not only that as a comprehensivist, there are great plurality of these generalized principles, and not one of them ever contradicts the other, but in fact, they are all inter-accommodative, and some of them are exponentially inter-augmentative. To come then, what you now would call a design would be where, in contradistinction to disorder, randomness, a design is where there's a deliberate ordering of the parts in relation to one or the other. You find then an a priori universe that is inherently complementary, and that there's this great orderliness, is to say, you and I are gradually discovering a great design of the universe itself, the eternal universe, in contradistinction to the time very limited and very inadequately observed experience, because you and I, all human beings, there's a second look, and in doing that, like everything else has changed, so you and I are always seeing things in aberrated ways, and what we really always call life is sort of an aberration, and each one sees it just a little differently. But a big thing here is that I became overwhelmed by realization there is a fantastic integrity and harmony and competence operative, which you and I just get little glimpses of. So I've always been moved by that, and I think Einstein made that clear when he wrote his beautiful piece in 1930. He wrote a piece called became well known, the anthropomorphic concept of God. And he talked about the faith that must have driven Kepler to live the nights of his life alone with the stars, his faith in the orderliness of the universe. And the people who had been called the great heretics by the church, Einstein pointed out, to him were probably much more driven by a greater faith in the cosmic, he could use the word cosmic religious sense, you may remember.
I do, and I remember that Lauren Isley, a scientist and also a poet, and somewhat, I think, less mathematically minded than you, thinking of us as originally water-oriented, water-borne organisms, that he said we dragged a sack of water out of the ocean and we walk around on land as a sack of water. But he, looking out of a train window at a burning dump between New York and Philadelphia, began to speculate whether it was not true that man was always in search of a system and never found it, and that really the cosmos was a burning dump, just like the one he observed between New York and Philadelphia. That seems an argument that the totality, the gestalt of the observable world is much less organized than you think it is. Do you find that people question you often on your belief in the ultimate organization of everything?
I've a great many questions, and particularly from young people. And I simply give them my best, what I see. But I have written now really quite a lot of books. I have 12 of them, and my book, which is just coming out, my Synergetics, using that name, I really do as best I can, and it is the very essence of what I think in the terms of the mathematical patterns and so forth. It is very much described in words, and you can feel the things in your senses. But as I take total inventory of what we have found out so far, as for instance, as far as physics knows today, there is no experimental evidence of energy being created or energy being lost. So we have apparently an eternally regenerative universe. That's quite a piece of design. Though the physicists use the word particle, he agrees that it does not mean a thing, it is an event. We're then finding this great complex of events, where such 92 regenerative chemical elements, which are events, and that they absolutely are elements because they are so utterly unique in respect to one another, that we have incredible numbers of the universe continually intertransforming, following various rules and options. And for instance, we find that really, this is fascinating mathematics becoming supplementary to Euler's topology. And I think it would be nice just to say what Euler's topology was. He did not describe it this way himself, but he discovered that all visual experiences are reducible to three ways of illustrating them. There'd be a trajectory or a line. When two trajectories cross one another, or the line comes across, you get a fix. Mm-hmm. And a fix is not to be mixed up just with a line. And if we have then a plurality of these lines, they cross each other and make an area. The areas and fixes and lines are all there are. And any picture you've ever looked at, you can say that that's either a fix, a point, or it is a line, or it's an area. And the children discover this really very quickly as they begin to play around with pencils. Now, he then discovered that speaking of any system, as for instance any polyhedron would be a system where it's a complex one like the Earth or a crocodile, he said that the numbers of the fixes plus the numbers of the areas will always equal the numbers of lines plus the number 2. I made further mathematical discovery of this when I began to go into my geometry, because I use vectors in my geometry. A vector is a line which has a discrete direction, angularly describable, in relation to an axis of observation, you and I. And its length is multiplying its velocity times its mass. It doesn't go to infinity. So I was very interested in vectors for geometry instead of lines that seemingly go to infinity. I found then that when I got into my vectorial geometry, this is fascinating, Euler, and getting up this beautiful inventory where you now know the whole behavioral whole in some of the parts, you find out about other parts. We find that he also invented a structural analysis of engineering, and he recognized that any object, no matter how asymmetrical, had a neutral axis of gyration, which you had to find in order to discover the strength of that piece. Now, he therefore really, in saying an axis of gyration, he really had a 2, but he never identified the 2 in his formula. The fixed crosses plus the areas equal the lines plus the number 2. He never identified that with vertexes or of axes of poles. So I said I'm going to take out of every system 2 vertexes to act as poles. And when I did, then I could take the 2 off this end over here, the plus 2, on that other side of the equation. Therefore, I next came taking inventory of everything, and found that all the anything you describe, any kind of polyhedron, that for every vertex that was, in addition to poles, 2 vertexes of poles, in addition to it, for each vertex and a crossing, a fixed in the universe, there always are 2 areas, and there always are 3 vectors. But there's also always a concave and convex. All the inventories always add up to 2. So there were 6 vectors, 6 lines for every event in the universe. There are always 6 lines. That you have a game of chess here, an omnidirectional, where every move every time you have a turn to play, you have always 6 moves, not just 1.
In terms of the things which are always, Buckminster Fuller, the mathematical discoveries which give a shape to things, you have determined that perhaps the most satisfactory shape is the tetrahedron. What is a tetrahedron, which is what you think of as the most?
It has 4 faces. The reason I can really tell you quite quickly why I see tetrahedron important, and that'll tie up to your comfort, and there are always 6 edges, or 6 lines for every move, for every turn. I became fascinated in what it is that I'm conscious of doing when I say I'm thinking. I observe people say he had a bright idea, and I don't know what that really means at all. But I've discovered my conscious part of thinking is that I'm spontaneously intrigued with something. I think something's going on here. There's some relationship I haven't been able to puzzle out yet. And so I said, today I'm going to get that. So what I do is all of us are continually asking ourselves questions, and we have feedback. We don't, when you and I say, what's the name of that friend of ours, you know, that MIT man, the blonde, say, yes, and then tomorrow morning you remember it. As we have experience of asking ourselves a question, and searching goes back in the brain, retrieves it. The other kinds of thoughts are not quite so slow. So I find that the rate of recovery is very unpredictable. Therefore, there's sort of a conglomerate of information. When you're not trying to say, I want to concentrate on something, and bother, no, there's something else. Oh, yeah, that's very attractive. So, my conscious part of thinking is to say, that's a very interesting, but keep out in the anteroom for a minute. I would like to consider you later. But for the moment, I'm really considering this thing that I'm intrigued with. So I find my conscious part of thinking is to put aside temporarily irrelevances. And because our experiences are inherently omnidirectional. Our earth is revolving, and we're looking all kinds of directions. We are revolving, so we look in all directions. So when I dismiss irrelevances, experiences, I discover they fall into two main classes. All experiences are too large and too infrequent to in any way alter the size of the things I'm being considered. I'm not interested in novae right now. They only occur very, very infrequently. Then all the experiences that are irrelevant because they're too small and too high frequency to in any way measure at the magnitude I'm considering. This is a sort of a tuning. When we begin to do this, a tuning. I found then that thinking subdivides total experience of humanity, which man cannot think about at any one time. Thinking then takes a subset, and I call it a system, a thinkable set. And a system divides the universe, and all the universe is outside the system, all the universe is inside the system, and a little bit of the universe which is a system which does the dividing. And that's what happens every time you're not really trying to picture something, get connections. So then I said to myself, how many stars would it take to define insideness and outsideness? I found 2 stars had betweenness. 3 stars have betweenness, not like at 4 stars, I have insideness and outsideness. These are the 4 points of the tetrahedron, opposite the 4 faces of the tetrahedron. Now the interesting thing about the tetrahedron is that while there are 4 points, there are 6 edges. As the interrelationship of four phenomena always has 6 special relationships. These 6 happen to be this is then what I call a minimum system in the universe. It's a terminal case. So the next thing, we have what we mean by structure. And I found that I have a necklace of many tubes and so forth, very, very amorphous. If I have 4 of them, they're still very amorphous, hanging on my shoulder. Not till I get to 3, getting the minimum polygon, that's the last case, then suddenly it is stable. It does not drape the way the necklace is done. A structure is a complex of energy events that interact, produce a stable pattern. And the only one that does that is a triangle. So the triangle happens to be the minimum polygon. You can't have less than 3 sides. Therefore, I've got a limit case of structure and limit case of system. So tetrahedron is all triangulated. 4 triangles, therefore, it's the minimum structural system in the universe. And it has 6 edges. Now we're talking about vectors. Every event has an action, reaction, resultant. So there are 3 vectors. And these 3 vectors interact. They don't operate 180 degrees. It's just the thrust wave of a motorboat, you see, coming out at an angle like that, and the bow wave makes a 70-degree angle. So that the action, reaction, resultant are not the same. There are 3 vectors. Now, in physics, we find then in this, talking about proton and neutron, the proton as an event has a reaction and a resultant. And the neutron has this as an event that has a reaction and resultant. And the proton has its electron and its antineutrino. And the neutron has its positron and its neutrino. And those are pictured as 3 vectors. And each one is called 1/2 quantum in quantum mechanics. You take the 2 of them together, you take those 3 and these other 3, and you find you make the edge like that, and they're the 6 edges of the tetrahedron. So they come together to make one structural system.
Everything seems always to come back to, well, I remember a line of Huxley's about a man who had sought the ultimate answer through numbers, that in numbers somehow, somewhere, the right numbers, if discovered, would answer everything. And although this, in a sense, as you say, when you answer something, you discover a mystery.
Mm-hmm.
I think you said that earlier. You answer a question, and then you discover a mystery, and then perhaps in your excitement over the discovery, you forget the mystery. And this goes back to something you said in one of your writings, that perhaps sailing was the beginning of science, that when mysteriously a man was able to sail against the wind by tacking, it seemed so mysterious. It was an exciting discovery, but he quit thinking about the mystery because he was managing to sail against the wind.
I think what I said was that the offshore navigation that you were able to do brought about the mathematics, because you have nothing to go by but your little ship, and you take two stars. You seem to be going from this star over here to that star, and that's the way these early Polynesians did. And we now realize that they've discovered navigation long, long before the Europeans. We just learned that in the last quarter of a century. So I said mathematics, I think, began at sea, because that's 3 points give you then. Out of this came the trigonometry, really understanding angles and learning where you are. But again, that is a priori mystery.
Well, I was just thinking of that because it seemed to illustrate your principle that there is a mathematics, there is a tremendous mystery. In a way, they have discovered the value of the triangle without knowing of the physics, which is the mystery which will come afterwards. But very quickly they were engaged in taking a cargo of something somewhere and bringing a cargo of something else back. And once a mystery becomes a tool, we cease to have the respect for it that we used to have, which I suppose is why we have so many tools now. There is among the young in particular a certain anti-science feeling that science is the enemy. Does that seem to you an odd response?
When I hear things like that in my day, and I realize that the Russia, China, United States, NATO putting $200 billion a year for Armageddon, I also have to realize that they're appropriating about $20 billion a year for psychological warfare, psycho-guerrilla warfare. And so the enormous amount of cross-roughing goes on, where one economy tries to break down the other one's confidence in anything. And I think the psycho-guerrilla warfare was really World War III, and it's all over, and the United States lost. And so there's a great deal of dismay in the discussions here that you would not probably find in China, for instance.
Well, they have come to the conclusion, I gather, and I have not been to China nor read all that much about it, but that a kind of anti-individualism is a part of their feeling, that individualism, although it looks good on the surface, has certain destructive qualities, that as a gestalt can be a principle, so the efforts of a great number of people toward a single end is probably better than the efforts of a number of people going in all directions. But what do we do with the left-handed scientists in such a situation?
Sir, one of my classmates at Harvard, Brooks Atkinson, and he and House and Salisbury were the last of the New York Times men to have close contact with Mao and Chu before the United States broke away from them. And they both tell me that Mao and Chu convinced them that the only way they could really possibly handle almost 1 billion people in abject misery as a consequence of incredible anarchy of great military leaders. The only way they could really put them together was by industrialization, but particularly by communism. It had to be absolutely rigorous. Now, I couldn't get a better reporter on communism, really, than David Rockefeller, who would be called a great capitalist. And David came back from China after making arrangements for his bank to be operating there as an import-export bank. I asked him if he would give me, could really tell me about China. And he said, Bucky, in 25 years, almost 1 billion people completely eliminated all prostitution, all venereal disease is gone, all narcotics are gone, all crime is gone, and everybody's eating. And this is an incredible thing to accomplish in 25 years. We said the price is very high. It means that I might not be able to see my wife possibly for 2 years, or maybe not at all. The individual really is submerged. But the wisdom of China is such, am I talking with Brooks Atkinson, the feeling that these are the first things first. They had to get looking out for the people, and then the wisdom can come, the freedoms can come. Otherwise, I would not really look on China as something frozen in that pattern. It's the first things first, sir.
Now, we have discovered in the course of this conversation some principles which, as I said, I thought were comforting, because anything which is always suggests an organized cosmos. Are we, at this stage of our development, mankind, Chinese mankind, Russian mankind, American mankind, are we sufficiently able to grasp all those principles, or are there going to be just a few of you pioneers and the rest of us stumbling around in the dark? Do you think you can spread the word?
Well, I'm very highly confident it can be done, yes, sir. Because I've been meeting large numbers of audiences who have literally asked me to come. And I have found that there's not a principle that I haven't been able to make that audience understand. I find as society begins to understand its principles, they are communicable. And that really became the very essence of my book, Synergetics, comes from it. When I was in 1917, I said, I don't think that nature has a department of mathematics, department of physics, department of chemistry, department of biology. It has to have a department that had meetings to know what to do in the leaf falls in the water. I think she has only one department. I don't think she has any irrational numbers like pi, transcendental irrational, because all the chemistry is so associating, dissociating, beautiful whole number. So I've made up my mind way back when I was really very young, if I could possibly, I was going to try to find what that coordinate system of nature really might be. And also then I felt that this might close the gap between the humanities and the sciences, because the reason people didn't understand was things seemed very obscure. And I said, I think all of it can be understood. And so this book of mine, Synergetics, really is the consequence of a whole lifetime of searching. I'm absolutely confident I really have found the coordinate system of nature, and it is rational, and it is all conceptual. So I think conceptuality is going to return to science. In the middle of the 19th century, when electromagnetics came along, contradistinction to steam, which you could see and understand the valve, how the steam was going to do this work, when the humanists asked the scientists what's going on here, electromagnetic, they said, we can't tell you. The humanists said, I've got to have a model, because I have to describe the model to the public so they can understand how this energy being generated gets over there and does all this work. And the scientists said, we're very sorry, it's actually invisible, and we can handle it mathematically. It moves a needle, and we have quantation. We can calculate then the consequences of another winding around the magnet, another copper cycle. And so we know just how we get results. In the middle of the 19th century, the scientists then doing this didn't like saying to the humanists, we can't really tell you. But anyway, they suddenly, in making measurements of energy, found black body radiation. Black body radiation brought about a fourth power, or what you might call four-dimensional. And they said, the scientists said, X, Y, Z coordinates which they were using, we only have 3 planes here, and you can't find another perpendicular to the system that isn't parallel to one of the lines already. Therefore, as much as nature is quite clearly using fourth dimension, or she is not using a model. So, middle of the 19th century, science went on, what we call flying, went on instruments, and never looked out the window again. And they've not been really trying to get society back in. So what my book, Synergetics, is about is to try to bring back that gap, and all the great scientists who've been really willing to take some time to look at what I have began to agree it does almost look like that. So it's going to be highly controversial, and it does not accept any of the axioms of mathematics, where mathematicians say there's a straight line. I say you can't make a straight line. Physics has found only waves. There are no straight lines.
Well, now, it may be that Synergetics will be highly controversial, but here today you have made one convert, and I hope that many among those who are listening have become converts to what I think of now as a rather more friendly universe than I did before beginning to speak with Buckminster Fuller. I thank you for being with us today, Mr. Fuller. This is Haywood Hale Broun saying goodbye for the Literary Guild's first edition.